Hai guys, kita jumpa lagi. Nama Rita kita semua, Ana. Okey, kita sambung dengan perbincangan Open Book Quiz 5, Chapter 2, Forces and Motion, tingkatan 4. Okey, first questions, what is work? Okay, if we recall, work, W, equals force multiplied by displacement. Okay, whereby force and displacement, they must be parallel. Alright, so if I am to define work, so work is the product of force and displacement in the direction of the applied force. So that is the definitions for work. Question number 2. What does principle of conservation of energy say? So the keyword here is conservation. It means that what I have now, I have it later, I will have it at any time, the same amount. So what does the principle say? It simply says that energy, you cannot create it, you cannot destroy it, but energy can be transformed from one form to another. For example, we have electrical energy transforms into heat energy and also light energy. But the total amount of energy remain the same. Okay, that's what this word conservation means. In Bahasa Melayu, conservation is abadi. We go to question 3. I have a small car of mass 100 kg moving along a flat road. The resultant force on the car is 200 newtons. So what are the information that we have from the question? So first, I have my mass is 100 kg. And then we are also given that force is 200 Newton. Okay, so question A, what is the kinetic energy of the car after moving through 10 meters? Okay, so I need to relate energy, okay, to force. And here I am given 10 meter displacement. I do know that energy is related to work. What is work equals to? Okay, work equals force multiplied by displacement. I do have my force, that is 200 Newton, and I do have my displacement, that is 10 meter. Hence, work done is 2000 joule. So what is my kinetic energy? So my kinetic energy is actually equivalent to my work. That would be 2000 joule. Alright. B. What is the velocity after moving through 10 meter? So we are still dealing with this 10 meter. Okay. What is the formula for kinetic energy? So kinetic energy equals 1 over 2 mv square, right? So my kinetic energy, it has been calculated just now. It equals 2000. Okay, equals to 1 over 2, and then my mass is 100 kilogram multiplied by the velocity square. And we saw for V, okay, you can proceed with the calculation and try to find out what is your V. Okay, my V here is 6.8 6.32 meter per second. Okay, so verify that the velocity is 6.32 meter per second. I hope that you can follow. All right. Now, let's go to question 4. I have a coconut fall from a tree from a height of 20 meter. What is the velocity of the coconut just before hitting the ground? Alright, so I have a coconut here. It falls down. Okay, the distance is 20 meter. Okay, it falls down here. So what energy do I have up here? Okay, I have my mgh plus my 1 over 2 mv square. Okay, but up here I don't have my kinetic energy, so that will be 0. Up here I only have my potential energy, gravitational potential energy. And then down here, okay, I still have my mgh potential energy plus 1 over 2 mv square for my kinetic energy, but my gravitational potential energy is 0. Why 0? Because the height here, h here, is 0. It is on the ground. There is no elevation. Alright, so from the principle of energy conservation, whatever I have at this point here, okay, I call this as my E initial, must equal to my E final here. Okay, that is what stated in the principle of conservation of energy. So I can write E initial, okay, equals to my E final. So E initial, I have my m, g, h. E final, I only have 1 over 2 m, v square. But the mass of the coconut is the same, right? It's a constant. So we can just cancel the mass out. So now your formula, you only have gh equals 1 over 2 v square. So let us substitute the value. G, that is 10. H is 20. Okay, equals 1 over 2 multiplied by v square. Alright, so we solve for v. Alright, so my v here, my answer is 20 meter per second. So verify that v is 20 meter per second. Actually, you have answered this question by you using a different equation. Okay, you are using the equation for linear motion. Remember this, s equals to ut plus 1 over 2 at square. Okay, so for this question number 4, we are using our principle of conservation of energy to solve for v, for velocity. Alright, so let's move to question number 5. What is power? Alright, what do I know about the formula for power? So we write power equals to W over T. Okay, if I am to put this into words, I would say power is the rate of doing work. Okay, work is something that we do. So we simply write the definition as rate of doing work. But remember that work is interrelated to energy. So I can also write W over T equals to E over T. So power is also the rate of change of energy. So you can say power as the rate of doing work or the rate of change of energy. Either one is correct. Alright, so let's move on to question number 6. Now we have a weightlifter lift 180 kg of weight from the floor to a height of 2 meters in 0.8 seconds, and you are to find out what is the power generated by the weightlifter. Alright, let us list out all the information first. I have mass is 180 kilogram. Alright. And I do have the height, that is 2 meters, and then I have the time, that is 0.8 seconds, and I am to find power. Okay, so what is power equals to? Power equals to work divided by time. Correct? Now, what is work equal to? Work is force times displacement over time. So, the weight is here and then it is lifted up. The height here is 2 meters. So, this here is our displacement. Alright. I do have my mass 180 kilogram. Okay, I have 180 kilogram. So this will give us the weight. Weight W equals mg. So 180 multiplied by 10. So I have 1800 Newton. 1800 Newton. So this is actually our force. Alright. So let us substitute the value into our equation here. So my force is 1800. Displacement is 2 meters. And then we divide by the time taken is 0.8. Alright. So what do we get? You should be able to get the answer 4500. Okay, that will be joule per second. Or you can write this as 4500. The unit for power is watt. Okay, it's spelled W-A-T-T. Alright, so that's how we calculate power for questions number 6. Okay, we move to question 7. What is efficiency? Alright, so efficiency is always the output divided by the input, correct? Alright, if we still remember, our efficiency equals to energy output divided by energy input multiplied by 100%. Okay, what comes out and what comes in, huh? Or we can also write this as power output divided by power input multiplied by 100. Because if I divide E output by T by time, you will get power. Alright, the same thing goes to input here. So how do we define efficiency? So efficiency is the percentage of the input energy that is transformed into useful energy. So this output energy is our useful, okay, useful energy. Alright, so that is our efficiency. So let's go to question number 8. Now, We have an electric motor in a toy crane can lift a 0.12 kilogram weight through a height of 0.4 meter in 5 seconds. And during this time, the battery supplies 0.8 joule of energy to the motor. Alright, so let's analyze the question and try to list out all the information given. Okay, so here we are given the mass. So the mass is 0.12 kilogram. Alright, so the height, the displacement, in other words, is 0.4 meter, and then the time is in 5 seconds. And then here, during this time, the battery supply 0.8 joule. So what is this thing actually? What energy is this? So that is our energy input. Okay, equals 0.8 joule. Alright, so calculate the useful output of the motor. Alright, so energy output. I'll just simply put O here. I use O for output. Okay, so energy output is actually equals to work. Okay, work equal to Fs. Alright, since we are lifting something to an elevation to a height, so I can also write this as my mgh. Alright, that will be the gravitational potential energy. They are all the same. Alright, so what is my mass? It's 0.12, gravity is 10, and then the height is 0.4. Okay, so calculate it. You should be able to get 0.48 joule. So this is the useful energy, our output. Okay, try to understand how we work the problem out. Alright, so let's move to part B of the question, the efficiency. Okay, so efficiency equals to the output energy divided by the input energy multiplied by 100%. Alright, so what is the output? 0.48, and then the input is 0.8 multiplied by 100%. Alright, so that shall give us 60%. So that is the efficiency of the motor. Okay, let's move to question number 9. Now I have a sales assistant at the shop transfers 50 tins of milk powder from the floor to the top shelf. Each tin has a mass of 2 kg and the height of the top shelf is 1.5 meter. So again, if you understand this question, what energy do I have? We are lifting it to an elevation, to a height. So we are having our gravitational potential energy. So if I am to calculate my work, I can simply calculate my, yes, my gravitational potential energy, mgh. Alright, so the mass, okay, the total mass of the tin, I have 50 tin altogether. Each tin is 2 kilogram, alright? So the total mass in the question is 100 kilogram. And then the height, okay, the height is 1.5 meter. That's the height. Alright. So let's answer question A. Calculate the total work done by the sales assistant. So, like what I have mentioned just now, to calculate the work done, I can simply calculate my gravitational potential energy. Alright, so my mass is 100 kilogram, G is 10, and then the height is 1.5 meter. Alright, so work done is 1500 joule. That is the work done. Okay, let's go to part B. What is his power if he complete the work in 4 minutes? Okay, see here you are given the time in 4 minutes. Alright, so the time is 4 minutes. But we don't work in minutes. We work in second. We prefer working with second. Okay, so we are going to convert this minutes into seconds. So just multiply this by 1 minute is 60 seconds. Alright, so I can cancel my minute. So the time is 240 seconds. So what is power equals to? Power equals to the rate of doing work, that will be W over T. Okay, so work done is 1500 divided by the time 240. So you will end up with 6.25. Okay, you see here, up here is joule, down here is second, so I have joule per second, but joule per second is watt, right? 6.25 watt. All right, so try to understand how we work it out. All right, before we move to question number 10.